Okay, we're talking about inverse functions today. This is chapter 5.1, the first part of it. And inverse functions are functions that kind of undo each other. So we have two functions here, f of x equals 8x and g of x equals 1/8 x. Okay, so if we put a value of x in for the first one, f of x here, remember that f of x means that we're going to put a value of 10 here. I just chose a value of 10 at random because it's easy to work with. Remember, f of x is also a fancy way of saying y. And the f of 10 means that we're going to put 8 times 10. We're going to use 10 as our value of x. And of course, we chose easy numbers, so that makes 80. Okay, so inverse functions, they undo each other. So in this case, we put in f of 10 equals 80, right? So now if I put in g of 80, what am I going to get as an answer? Well, of course, I picked an easy example. So 1/8 of 80, where 80 is my input to this function, is going to give me a value of 10. So these two functions are inverses of each other. If I put in a value of 10 here, I get a value of 10 over here. So the input for the g of x, it came from the output of f of x. So this 80 here, this is the output, and this is the input of those two functions. We started out with 10, and we ended up with 10. These are inverses of each other. Okay, one-to-one functions. Reason we're talking about one-to-one functions is that only functions that are one-to-one can have inverses. So this is the most important part of this part about we're talking about one-to-one functions. So I'll read the mathematical definition of it and explain what that means. A function of f is one-to-one, is a one-to-one function if for elements a and b, from the domain of f, if the two things are not equal, we have two different values, implies we get two different outputs. So these are two different values of x. A is not equal to b, implies that remember this is a fancy way of saying y, the f of a and the f of b are not going to be the same answers. Okay, so if we put different inputs, we're going to get different outputs. Different numbers here, different a's and b are not equal to each other, then the output, the y values, are not going to be the same at the other end. Okay, so how do you tell if a function is one-to-one? Well, we go back to that definition. If I put in different values of x, I should be able to get different values of y, and there's no values of x. If I put in different values of x, I should not be able to get the same values of y. So we'll kind of do an example here with these two. Let's see it determine if they're one-to-one. So if I put in f of 3 in the first one, so my x values are going to be 3. I'm going to get negative 4 times 3 plus 12 equals 0. And I'll use f of 2 for another value here. And I'll get, let's not use 2. I'm going to use negative 3 instead. Negative 3, 4 times negative 3 plus 12 is going to give me positive 24, right? The two negatives make a positive, get positive 24. Okay, so I use those same values of x over here in my other function. My function has the square root in it, and I get f of 3 equals the square root of 25 minus 3 squared, which is the square root of 25 minus 9, which equals the square root of 16, which equals 4. Okay, so if I do the same calculation again with negative 3, what am I going to get for an answer? And if we work this out, 25 minus negative 3 squared, I'm going to get the same thing, right? The 25 minus 9 squared equals the square root of 16, which equals 4. So in this case, I got the same values from different. Negative 3 gave me 4, and positive 3 gave me 4. So this is not one-to-one. And this one is one-to-one. And you can use your common sense on this, your mathematical sense, to see that, yeah, this one I can tell without doing any examples, that if the x's are different, then the y's are going to be different. It's a pretty basic equation there. And almost every time, I can't think of any examples where you wouldn't, but if you have an x squared, it's not going to be a one-to-one with that x squared in there. So anytime you have an x squared, you'll probably be pretty suspicious that it's not going to be a one-to-one function. Okay, the other way you can tell if functions are one-to-one is using the horizontal line test. You can use your calculator, graph these functions, and then look at them and see if there's any place where a horizontal line is going to hit the graph more than in one point. Like in example A here, they draw a horizontal line. It hits the y value in 3 places. Okay, the function here, the first one has got this up and down motion in it. It's got the 3 different values of y for 3 same values of y for different values of x. So that makes it not a one-to-one function when you have that situation going on. The other side here is a straight line. The B side here, it is a one-to-one. Just a straight line going down, a negative slope, but for every y value, for every x value, there's a unique y value. So that makes that a one-to-one function. Okay, inverse functions. You can tell algebraically if you can figure out if 2 functions are inverse functions, and this is the mathematics behind it here, that let f be a one-to-one function. So you start out with the one function, then g is the inverse of function f, and f is the inverse of function g if these 2 things are happening. If f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. And we have those composite functions here. We have f of g of x and g of f of x is how you say that. But I'm going to show you what they mean when they do that. We've had these composite functions before, but it's maybe been a little while since we've done them. So I'm going to go through with these 2 examples on the next slide and show what they mean by that these 2 functions are, you can show algebraically that these 2 functions are inverses of each other. Okay, so we have these 2 functions here that f of x is x cubed minus 1, and g of x is the cube root of x plus 1. Okay, so how do you prove? We want to prove that these 2 things, when we do the f of g of x equals x and g of f of x equals that. So remember, when we do these composition functions, it looks like this, f of, and then we can put in g of x. Okay, and we can do the same thing for the other side, the g of f of x. You kind of write it like that, so it makes it a little more clear what we're talking about on this one. So to do this, we would write it out wherever we had a x in f of x, we would put the g of x. So I would write it like this, f of, and now I'm going to write f of, instead of writing the x cube, let me erase that. So I'll just write it out. Okay, so I'm writing out the first one here, and I'll write it out like this: f of g of x. And since g of x is x to the third power, I would write it out like this. I would write the g of x in the middle first, the cube root of x plus 1, and then I would cube that and minus 1, right? The f of x is whatever we had x cubed, right? It's whatever this is my x part here underlined in green, the x cubed minus 1. Well, when I do the cube, when I have a cube root and I take, cube it, I just get back what I started with here. So I get, on this part, I just get x plus 1 and then minus 1. So the plus 1, the minus 1 cancel out, and I just end up with x, which is what I wanted to do. I wanted if I take these two functions, put one inside the other, and it equals x, then they're inverses of each other. And I can do it the same way over here. Okay, so if on this side, I take I'd have to take the cube root. I'm going to use the red pen here. I'd take the cube root, and then wherever I saw the x in this one, I would put x cubed minus 1, and then I would do the plus 1, right? The plus 1 is that this is instead of, I'm writing this instead of x, right? And then also I forgot to put the cubed on the outside. Okay, so this part that I wrote here in green is what is, it's normally it's x plus 1, the cube root of x plus 1. But now instead of writing that x there, I substituted in the f of x function, and I got x cubed minus 1. So this one, it turns out when we do that, we get the cube root of x cubed minus 1 plus 1, which equals the plus and minus 1 cancel out, of course. Then you get the cube root of x to the third, and again, the cube root cancels out the x cubed, and I just get x, which is what I was going for. And that's how you can prove algebraically that two functions are inverses of each other. And that's the end of the lesson for the first part of 5.1.